Okay, so these are our notes on circles, and this is the first set. We'll be doing multiple sets. Um, this is all about circles, and our first word here that you're going to fill in on your notes that match this is circle. A circle is a set of all points. Okay, so a circle is a set of all points in a plane. So it's a two-dimensional figure. All the points are equal distance from the center of this circle C. And here's how we refer to it. We can call it circle C if the center is labeled C, or you could draw that circle with a dot in it and put a C beside it. So that's just some notation you might notice. The interior is the set of all points inside the circle. And the exterior is the set of all points outside the circle. Exterior. Let's see if I can spell that right. Okay. Remember, you can always pause the video if you need to slow it down to write things down. Now, a chord is a segment whose endpoints lie on a circle. It's spelled the same as a chord in music. So, for instance, in this picture, AB would be a chord. Now, a secant is a lot like a chord, but it's just a line that keeps going. So that's spelled S-E-C-A-N-T if you can't read that. This line L on your sheet is a secant line. It intersects the circle in 2 points, and it's a line that keeps going. I wouldn't label that a segment just because it does keep going. And then a tangent is a line in the same plane as a circle, and it intersects the circle in 1 point. In order to do that, it's kind of like it comes along and it hits it at a point and it just keeps going. So the point that it hits it at is called the point of tangency. Okay, so I've labeled those here. Point of tangency and the tangent. The tangent's the line, the point of tangency is the point on the circle where it hits the line. One of the things you're going to, it'll be presented to you later, but I'll go ahead and tell you now. If I were to take a radius of the circle to that point of tangency, it ends up being a right angle. So I can get some right triangle type problems out of this setup. So that's one of the reasons, that's one of the ways you'll see point of tangency. It's one of the reasons we wait to do circles until after we've done perpendicular things and right triangles. Okay, so at the bottom of the page it says identify each line or segment that intersects circle L. So chords, okay, well there's a chord at KM, so I'm going to put KM. Okay, app is glitching here. If I just look at the points, I'm just going to draw a segment over that to show that it's a line segment. If I just look at the from J to M, just the segment, I could actually say JM was one, but not the line JM. As a matter of fact, the line JM I would write with the arrows over it like that and put JM. Now that's a secant line because it keeps going. A chord has to go all the way across the circle. It doesn't have to be a diameter. It could be, for instance, here's another chord that I'm drawing in, something like that. So don't get the idea that it has to be a diameter or something. It doesn't. Now the tangent line is this line M right here, so I'm just going to write line M. The diameter is KM. That's like two radiuses put together. They go, well, two radii put together. They go straight across the circle. And then the radii, there's lots of radii here. There's LM is a radius. I'll put a segment here. LK is a radius because it starts in the middle and goes to the side. And if I stop at J, LJ would be a radius. So we got a lot of those there. All right, now on page 2, it's a little blurry here, but you can look at your handout and fill in the deals. Even if this is a little blurry, you can still see your handout. Two circles are, we would say, congruent, if and only if they have congruent radii. So if they have congruent radii, they're going to be exactly the same size. Everything else is the same on a circle. Now, concurrent circles are coplanar circles with the same center. We say they're concurrent. They have the same center. You think not concurrent. It is concentric. Sorry, brain is not still working. Concentric, sorry, that would be concentric. These two circles next to the sentence have the same center, so they're called concentric. With the same center is what that literally means. Two coplanar circles that intersect at exactly one point are called tangent circles, and you can see we can have, so you can put tangent in here. You can have internally tangent where they're tangent on the inside, and you can have externally tangent where they're just touching at one point where they connect, like on the right side. But tangent is what you would put in the blank. And then we'd have to say this is actually supposed to be an external tangent is a line that's tangent to two circles. We have two external tangents here. One is L and one is M, and you can see it's over here written also. Okay, we have a theorem that says if two tangents or two segments are tangent to a circle from the same external point, then the segments are congruent. So if you see in the little box, we've got the same thing going on over here in this example 4 here. If we want to find out how long one of these lines are, for instance, HG, I know that since both of these are tangent to the circle, HK and HG, and they come from the same point H, I know that I could set those two segments, since GH equal HK, then I can set the lengths of them equal to each other, so I could have a little equation, 4 plus 2a is equal to 5a minus 32. I'm going to move my a's all to one side. I'm going to subtract 2a from both sides. 4 is equal to 5a minus 2a is 3a minus 32. I'm going to add 32 to the other side, and that'll mean that I get, even though it's hard to read, 36 is equal to 3a. And if I have 36 is equal to 3a, and I solve for a just by dividing both sides by 3, I'm going to get a is 12. So I can tell if a is 12. Now that's not the length of AG. I have to plug that in, don't I? Because it's 4 plus 2a. So it would be 4 plus 2 times 12. Wish this would pick up better. 2 times 12 is 24. So I get 4 plus 24. That means that the length is 28.